Hi guys, welcome back to my channel. So in this video we're gonna go over Green's theorem. Alright, so the Green's theorem, you're gonna have an equation like this in the form of P and Q and dx dy. So for example, this equation that you have over here, we're gonna be solving this question in a moment, okay? So if you have something like this, so the first equation is treated as P and the second one is treated as Q. Because it corresponds to the x component and the second one corresponds to the y component. So the first one is treated as P and the second one is treated as Q. Okay, so if you have something in this form, so what you can do, you can take the integral of this one and you can, since P is associated with x and Q with y, so you're gonna take like a inverse determinant, so qx minus py like this, and then you're going to integrate it and use double integral to solve it, and that's how you're gonna obtain the simple closed curve. Okay, so the Green's theorem is simply a simple closed curve in the counterclockwise direction which starts and ends at the same spot. Okay, so if it starts from here, then it's gonna go in the counterclockwise direction. It's gonna end up at the same spot. Okay, and if you found using Green's theorem, you get 0. Okay, which means that the vector field is conservative and the work done is 0. So every time you have that, you don't need to do the double integral or anything. You simply, when you get 0 in here, which means it's conservative, and you stop the problem and you simply report 0. That's it. Okay, so the Green's theorem actually deals with the line integral of simple closed curve over non-conservative vector field. Okay, so like I said before, if you get 0, so that means the vector field is conservative. You simply report your answer as 0. If it's non-conservative, then you're gonna go ahead and solve it. Okay, so let's go ahead and solve this problem where we have here this closed integral over here. And we need to use Green's theorem to evaluate the line integral where C is the boundary of the region given by these points. So let's go ahead and plot these points. Okay, so I just drew the Cartesian plane. So we have our first point as 0, 0, which is nothing but here, 0, 0, this point over here. And we have our next point as 1, 1. So let's say this is 1. And this is 1, so we have our point over here, 1, 1. Okay, and then we have 0, 1, which means x is 0 and y value is 1. So we just plotted over 3 points. Now we need to join these points in order to create our region. Okay, so our region looks something like this. So now that we got our region, next, we need to solve this using the formula that was given to us, qx minus py. Okay, so then you guys know that this is p and this is q. And if it's confusing for you guys, so you can also write the equation in terms of our vector field. Okay, so the vector field looks like something like you have I hat plus j hat and then k hat like this, right? So you can write it in this form as well. So x cube I hat plus x y j hat. Okay, now it's easier for you guys to see that this is p and this is q, since it's associated with the I component and this is with q. Okay, so you just need to do qx minus py and or dA. So q x, that means partial derivative of q with respect to x, okay, and this means partial derivative of y with respect to, partial derivative of p with respect to y. Okay, so this is what these notations mean. So first let's go ahead and calculate the partial derivative of q with respect to x. So with respect to x, that means y is constant. Okay, so y is gonna stay over there, and the derivative of x is 1. So the constant stays over there, so it's gonna be only y. Okay. Next, what do we have? Py, partial derivative of p with respect to y, which means with respect to y means x is constant, okay? And we only have x over here. And what's the derivative of constant? Correct, that's 0. Okay. So once we have this, so y minus 0, that's only y. Now we need to figure out our region in order to find the double integral. Okay, and for this graph is going to help us. So you can go in the dx direction first or in the dy direction first. It doesn't matter which one you try to go first because these are constants, so it doesn't matter. So let's go ahead and go in the dx direction first. Okay, so every time you wish to go in the dx direction first, you're going to go like this. But if you wish to go in the dy direction first, then you're going to go like this, okay, from bottom to top, and for dx from left to right. Okay, so we wish to go in the dx direction first, so which means we're going to be writing our function as dx first and then dy, which means this has to be x equals to something, x equals to something, and then this one has to be y equals to and y equals to something. Okay, so what is the equation of this line over here that you see? Okay, so the equation of this line that you see over here, it's x equals to 0. Okay, and what about the equation of this line? So if you don't know the equation of this line, you can go ahead and pick 2 points over here and find the equation of this line. But it's a really simple line. You should know here it's 1 equals to 1, 0 equals to 0. So the equation of this line is simply y equals to x, right? So when you know that the equation of the line, but we don't want it in terms of y. We want it in terms of x. So y equals to x or x equals to y, it's the same thing. So that's how we're going to write it. So we got our lower bound as x equals to 0. And our upper bound as x equals to y. Okay, the left side of the arrow is always the lower bound, and the right side of the arrow is always the upper bound. Okay, now let's find for y. So for the y, it's never the equation. For the last variable that you see over here, it's never gonna be an equation. It's gonna be always a constant. Okay, so for this you only have to look at the y values. Where does the graph go in the y values? Okay, so the graph in the y values, where does the region belongs to in the y values? Okay, so the region belongs to y equals to 0 to y equals to 1. Okay, so the y values goes from 0 to 1. So the lowest y value is 0 and the highest y value is 1. So for the last variable, you only look at the lowest and the highest value. Okay, so for example, if you were doing in the dy dx direction, so here you would look at not the equation of the dx, instead you would only look at the lowest value of x and lowest value of y, referring in that case it would be x equals to 0 to x equals to 1. Okay, so I hope you got it. So let's go ahead and now finally solve our integral. Okay, so we're finding y dx. So y in terms of with respect to dx, which means y is a constant over here, and we need to put an x in front of it since it's a constant. Okay, now evaluating with respect to x equals to y and x equals to 0. And yeah, not forgetting about these points. If you want, you can write them at the end as well, but make sure to write them. Okay, now plugging in x equals to y and x equals to 0 in this equation. So we're going to plug in first y. Okay, we're plugging x equals to y in this x. Okay, and then subtracting y, and now we are going to plug in this x equals to 0 in this one. Okay, so that's gonna be 0. Okay, and y times y, that is gonna give us y squared. Okay, so we have y squared, y equals to 0 to y equals to 1, and then we have dy. Now it's a simple integral with respect to one variable, not two variable. Okay, so that is gonna be 3 cubed over cube, y cube over cube. Okay, then we have y equals to 1 to y equals to 0. So then we simply need to plug in 1 and 0 in this equation. So we get 1 over 3 minus 0. So that's going to be 0. So our final answer is 1 over 3. Alright, let's do the next problem. Okay, so we have this problem where we need to evaluate this integral and given these region. So our first region is y equals to x squared and the second one is y equals to x cubed. So let's go ahead and draw this region first. So to draw y equals to x cubed, first you guys need to know how it looks like. So you don't need to draw it exactly to scale, just a rough sketch would do the job as well. So this is how it looks like, y equals to x cubed. Okay, and you guys probably know how y equals to x squared look like. Okay, so y equals to x squared looks something like this. Okay, so they're gonna cross out each other at one point, of course. Okay, so then this is the region that we are looking for. Okay, so now once we got our region, our next job is to, of course, use Green's theorem to evaluate this integral. So like I said before, to use Green's theorem, you only need to know one formula, which is qx minus py, right? And if you forgot, let me remind you how to get this formula. So it's really simple. You only need to remember p is associated with the x variable. Okay, so p with x, q with y, and you do the inverse determinant, qx minus py. So bottom to top. Okay, so you do qx minus py. So this is how you get it. Okay, so it's as simple as this. Okay, next, so the first one, if you want, you can write it in terms of vector field. So it's xy I hat plus 3 cosine y j hat, and this is our q, and this is our p, and this is our q. Okay, so you're going to evaluate this. So this one is q, and you're going to take the partial derivative of this one with respect to x. So q with respect to x, and there's no x you see over here. So x, which means y is constant over here. So you only have y and 3 over here, which means the whole thing is constant. So you have 0. This whole thing is constant. Okay, and next you have p with y, which means x is constant over here. So here the x is constant and you're differentiating only y. So here you have 2y and x stays over there since it's a constant. Okay, now you can go ahead and find the region of this one. So it's gonna be 2yx, and we are finding some regions over here. Okay, so like I said before, if you're going in the dx direction first, you go in this way. If you're going in the dy direction, you go in this way. Okay, so you can go in either direction, it's fine. Okay, so I'm gonna choose to go in the dy direction first. Okay, you just go in the direction which you find easier. Okay, so now here you need to know the equation of this line and the equation of this line. So equation of this line, I already wrote y equals to x squared, and the equation of this line, it's y equals to x squared. And we are going in the dy direction first, so we need to write dy and then dx, which means this has to be y equals to something, y equals to something, and the next thing has to be x equals to something. Okay, so here we need to write actually need our equation in terms of y, and we do have our equation in terms of y, so we don't need to do any work over here. However, if we were going in the x direction, in that case we will simply switch these, like x squared equals to y, then here it would be x equals to y squared. Okay, this is how you're gonna go in the x direction. But you don't need to worry about it since we're going in the y direction. Okay, so this is our lower bound, which is y equals to x cubed, and our upper bound is this equation over here, y equals to x squared. Okay, so x cubed is the lower bound and the upper bound is x squared. Next, what values do x belongs to? Okay, so this is 0, and what about this one? What is the intersection point? We need to know this. Okay, and I hope you guys remember from high school how to find the intersection point. Okay, so to find the intersection point, we do nothing, we simply equal the equation of two graphs that we are looking for. Okay, so we have this equation and this equation, and we're going to find, and we need to find the intersection of these two equations, y equals to x squared and y equals to x cubed. So we're simply going to equal these two equations, so x squared equals x cubed. Okay, and in order to solve it, let's make it all to the other side. Okay, so we get 0 here. Now you guys can see we can factor out x squared. So if we factor out x squared, we're left with 1 minus x squared equals to 0. Now we can make this equation equals to 0 and this equation equals to 0 separately. So here we get x equals to 0, and here if we move the 1 to the other side, x negative negative cancels out, so we have x equals to plus and minus 1. Okay, so we got this from this equation over here. So let's go ahead and find the y values of this one. So we got the intersection point for x. Okay. Oh wait, my bad, I made a mistake. So wait a second. This has to be x, not x squared, because x times x, that's x cubed. X squared times x, x cubed. X squared times x squared, that will be x to the power of 4. So I'm sorry, this doesn't have to be square over here. So if it's not square, then it doesn't give you plus and minus. It only gives you one value, which is x equals to 1. So you got two intersection points, one as x equals to 0 and the other one as x equals to 1. Okay, so x equals to 0, you already know it's x equals to 0, y equals to 0. It's this point over here. Okay, and for here you got x equals to 1. And if you plug the x equals to 1 in either of the equation, you get y equals to 1 as well. So this point is 1 as well. So you got the intersection point as 1, 1. So now that you know the x value, so now you know the lower bound, the lower value of x is 0 and the highest value of x is 1. So these are your constant for x. So this is what you need to know only in order to set up your integral. Now it's really simple. Let's go ahead and solve this integral. So we are integrating this with respect to y first, which means x is a constant over here. Okay, so x gonna stay over there. Okay, we're only differentiating, integrating y. So that's gonna become squared over squared because it's only y. We're gonna add 1 to it, plus 1, that's 2 divided by 2. So 2 cancels out. And now we need to evaluate this with y, and y equals to squared, x equals to 0, x equals to 1. Don't forget to write these. Okay, now we have this negative xy squared with respect to y equals to x squared and y equals to x cubed. Okay, and of course not forgetting these. Now it's simply to plug in y in this one. Okay, so first let's go ahead and put y equals to x squared in this y. Okay, so this is already y equals to x squared, right? So this is y equals to x squared, and we are replacing this y with this x. Okay, we're replacing this y with this x squared. This is x squared, and there was already a squared over here, right, in the y. So if you multiply this, so that should give you x to the power of 4 times x, right? Okay, next we're going to subtract it from, and then subtract it, and we already have a negative over here, so that's why I wrote negative x. And then here we have y squared already in the equation, right? But we're going to replace this y with this x cube. So we're going to replace this y with this x cube. So that's 3 times 2, that's going to be 6. And if you multiply this, that's going to be positive x to the power of 6 times x. So this is what you get after doing this. Now you're going to multiply these x's together, so x to the power of 5 plus x to the power of 7 dx from 0 to 1. Okay, now this is really simple. That's one variable calculus. So negative 1 over 5, sorry, negative 1 over 6. I'm sorry, I'm just going too fast. Okay, so since we're taking the integral with respect to x, so that's going to be only plus 1 to the exponent and divided by the exponent. And then we have plus 1, so that's going to be 8 over 8. And then we're going to plug in 1 and 0 in here. Okay, so let's plug in 1 here, so that's going to be negative 1 over 6. And then plus 1 over 8. And then we're going to subtract it from plugging 0 in this equation. So if you plug in 0, 0, you're only going to get 0. So now let's go ahead and evaluate it. So this gives you negative 1 over 24, and that is your final answer. Thanks for watching. Bye.